Hello, everyone. We're working on statistical methods for rates and proportions, Chapter 4, Section 4.4. We're going to discuss using unequal sample sizes. So just like in the case where we had equal sample sizes and we created a function to plot the sample size requirement and the power, we're going to do a similar thing, but we're now in the case where we have unequal sample sizes. So we're going to add one thing into the function that we create. So we're going to have P1 and P2, just like before, alpha, beta, and we're going to also have this value of R. Okay, so we're going to set Q2 and Q1 to be the probability of failure for each of the groups. And we're going to set our P bar values, but now our P bar is calculated slightly differently because we have unequal sample sizes. We're going to set our alpha level and our Z alpha over 2. And we'll set our Z beta. Once again, we're using this Q norm function in both these cases because we are feeding R an area and then we're asking it for the corresponding Z score. So first we calculate M prime, and this is based on the formula 4.19 in your text. And we calculate M after we find M prime. And the values for M can be found in equation 4.18 in your text. From there, we'd like to plot the value of M. And remember that M is going to be the number of people in group 1, and R times M is going to be the number of people for group 2. We're going to also plot the power. And remember, we're looking at the difference of proportions in this case. From there, I'd like to also output the values, which we're going to be given the number of people for group 1, the number of people for group 2, beta, and the power. So here, we're going to get Rm. When we look at this, we run our function through. And then we're going to do an example so we can see this in action. We're going to have our first proportion being 0.25, our second proportion being 0.40. We'll get our alpha level of 0.01. We're going to consider a lot of beta values, all between 0 and 1. And then we're going to set up R to be 0.5. So when we run this, we'll get our power curve. And it looks like just under 400 patients for group 1 is going to get us the power of at least 80%. Here we just had the table output any values of the power where we have more than 95% power. And in this case, we can see that it's about 531 patients for group 1. And since R was 0.5, we have 266 patients for group 2. That corresponds to a beta of 0.05, a power of 0.95. Then we have our alpha levels, P1 and P2. Okay, if we want to look at something more strict, let's say 98% power, we're going to need a sample size of 636 patients in group 1 and then 318 patients in group 2. So playing around with the alpha levels, the differences between P1 and P2, and then looking at the different values of beta and power can help you understand the relationship between power, type 1 error, and type 2 error, and the effect size, or the size of the difference between P1 and P2. I hope you learned a lot from this video, and I look forward to seeing you next time.